Hello, so today we're going to be talking about what influences the rate of a reaction. So here we have some rate expressions. This is a first order rate expression, second order rate expression, and so on and so forth. And so we can see that the rate depends on the rate constant and the concentration of the reactants. So one factor is just the concentration of the reactants. More reactants means faster rate. But what about this K value? What does K depend on? Well, we see that K is given by the Arrhenius equation here. So as we look at this equation, we'll notice, well, K depends on temperature, so temperature influences the rate. We also have activation energy, also influences the rate. And remember that a catalyst can lower the activation energy and thus increase the rate. So the presence of a catalyst is also a factor. And then this A here is the collision frequency, which can change if you're running a reaction in a different situation, like versus in the air versus an organic solvent. So collision frequency is also a factor. And for, say, if you have a solid reactant, if you have a solid reactant and it has a greater surface area versus if it has a smaller surface area, a larger surface area will cause the reaction to go at a faster rate because the concentration of the reactant, because that is greater. So another possible factor is for solids. For solid reactants and catalysts, a larger surface area. And so there we go. I would say that our main factors are the concentrations of the reactants, temperature, activation energy, and probably the presence of the catalysts. So there we go. We looked at some situations that would change